Okay, I'd like to walk you through a really clever algorithm for converting a binary number to BCD. BCD just means binary coded decimal, so essentially we're converting to decimal so we can display digits on a display. Okay, so I'm just going to show you how to do this. This is called DoubleDabble. It's a pretty cool little algorithm, and then I'll make a separate video that kind of explains how it works. So initially, we're going to go through some steps, and it's going to seem like kind of a mystery that at the end you end up with a BCD number. All right, so to get this started, we're going to take a number that we know, 178 base 10, that converts to 1011, 0010 in binary. Okay, so to get started, what I want to do is copy the binary number down. So we carefully copy that down. And then I'm going to make some divisions, all right? We're going to have 4 bits represent each BCD digit, okay? So that makes sense, right? It takes 4 bits to do BCD. So first of all, we'll have this column that represents the ones. Then we'll have this column that represents the tens place. And then this column is going to represent the hundreds place. Okay, so that's all I need for this problem. The biggest number is 178. Hundreds is the highest digit. Okay, so this is the hundreds place. All right, so DoubleDabble. The double means shift by 2. Okay, so if I shift a number to the left by 2, that's like multiplying by 2. That's like, with decimal, if you do a decimal point shift to the left, that's like multiplying by 10. Okay, so the double part comes from the shift. All right, so we'll do a shift first, and then we'll do a dabble. I'll explain what dabble means when I get to it. All right, so let's get started. The first thing we're going to do, I'm going to call this stage 0. Okay, so we're going to get to stage 1, and the first thing we're going to do is shift. Okay, so when I shift this over, I'll just copy the digits down, shift it over. So there's the shift. Okay, I'm going to also put a line here to denote the different stages as we go through it. Okay, so from there, what you do is you dabble. Okay, with each stage, there's a shift and then a dabble. All right, so what you do to dabble is you look at the number that shows up in this 4-bit place. Okay, you'd actually do it for all these places, but there's nothing there yet, so there's nothing to dabble. All right, so let's get rid of those for now. But you look at the number, and if the number is less than 5, you just keep it. If it's greater than or equal to 5, you add 3 to it. All right, so that's what a dabble is. Test it, see if it's bigger than 5, bigger than or equal to 5. If it's bigger than or equal to 5, you add 3 to it. All right, so let's get started. 1 is less than 5. Okay, so I don't do anything to that number. I just hold it as a 1. Okay, so I did the shift, which was the double, and now I did the dabble. Notice with the dabble, I just copied things over because nothing changed. So let's go to the next stage. Okay, so the next stage is stage 2. We will always shift and then dabble. Okay, so when I shift, this becomes 1 0 1 1 0 0 1 0. Okay, then I look to dabble. All right, so there's only this place right here. That's a 2. 2 is less than 5. So I don't do anything. I just copy this down. Whoops, you copy it down accurately. Okay, so there's the dabble stage. All right, so nothing's happened with dabble yet. We'll get to something happening here in a second. Okay, so now we go to stage 3. Okay, the first thing we do is we shift. Okay, so when I shift, I now get 1 0 1, and then keep going. That would be 1 0, 0, 1, 0. So I just shifted that over by one position. That's the shift step. Okay, then I check for a dabble. All right, finally a dabble. Because 5, 1, 0, 1 is 5. That means I need to add 3 to that. All right, so when I add 3 to that, 5 plus 3 is 8. 8 in binary would be this. So that's the dabble stage. Finally, something happened with the dabble. Okay, so now we keep going. We're going to do this for all the bits until everything is shifted into the hundreds, tens, and ones place. Okay, so the first thing we do is we shift. So 1, 0, 0, 0, and then this 1 shifts in, 0, 0, 1, 0. That was stage 4. That's the shift. Okay, then I ask myself the question, what do I do about dabbles? Okay, so I check these 4 bits. That's 1 is less than 5, no dabble. 1 is less than 5, no dabble. Okay, so in this particular case, you just copy down all the bits because nothing got dabbled. Next stage. Okay, so the next stage is stage 5. What do we do the first stage? Or in this stage, we shift. Okay, so that'd be 1, 0, 0, 0, 1, 0, 0, 1, 0. Okay, so now I check for dabbles. That's 2, no dabble. That's 2, no dabble. And so we've done the shift. And the dabble stage, nothing happens. Nothing was greater than, none of these dabble cases were bigger than 5. So we just copy down the result. On to the next stage. Okay, so the next stage, stage 6. Let me extend these lines down. So the next stage is we shift. Okay, so when I shift this over, this would be 1, 0, 0. This would be 0, 1, 0, 0. And then we have 1, 0. Okay, so the next thing we need to do is check the dabble. Okay, so when I check the dabble, that's 4. That's 4. Nothing to dabble. So we just copy these bits down. Getting close to the end. Step 7 is another shift. When I shift, this becomes 1, 0, 0, 0, 1, 0, 0, 1, 0. There's the shift. Now, this feels good because we get to dabble something. All right, so I look at this and I look at this. 8 is bigger than 5. 8 plus 5 is 13. So I write down 1, 1, 0, 1, which is 13 in binary. Okay. 8 plus 3 is 11. So I'm sorry, I messed that up. 8 plus 3 is 11. 1, 0, 1, 1. Okay. Next we have 9. 9 plus 3 is 12. 12 is 1, 1, 0, 0. And then I just copy down this 0. Okay, so that's the last dabble stage. And then the last stage is we shift everything over one more time. 1, 0, 1, 1, 1, 1, 0, 0, 0. Okay, by the time we get to stage 8, we should have the BCD representation. So I look at this, 0, 0, 0, 1, convert that to from binary, that's a 1. In BCD, 0, 1, 1, 1 is 7. And in BCD, 1, 0, 0, 0 is 8. So we get the result that we expected, 178 decimal. So we went through this process. We started with the binary number, go through all the shifts and the dabbles, and end up with this in BCD. Okay, so that's the basics of the algorithm. Next, on the next video, I'll explain a little bit more about why it works.